In this video, I'm going to analyze a sheet metal part using a laser cutting process and then determine whether or not an investment in a progressive die would be more cost effective. I'm going to do it using what I would call the sketch on the back of a napkin, but I do have a picture of what this part looks like. I'll load it into the picture box here, and I can bring it up here so you can see that it's just a simple piece of sheet metal. It's 4.331 inches in that dimension, just over 2 inches in this dimension, and about 1 1/3 inches in this dimension. And it's got 4 holes of one type and then 4 more holes of 2 different types and a bend. So in order to describe that in the DFM software, I would call this part the end plate. I would give it a part number if I wanted to, and I'd type in a production volume that I wanted to produce. In this case, I'm going to say 50,000. I'm going to call this a stepped block, and I'm going to put some envelope dimensions on it here that I just listed for you. It's 1.299 in height. In that direction, it's 4.331, and this width direction is 2.165, and it's actually 0.079 thick. And then select a process and a material, and we talked about using laser cutting as the initial process, so I'll pick laser cutting. And then under carbon steel here, I've got some different choices, and I'm going to pick the low carbon cold rolled commercial quality steel and say OK. Now I'm presented right away with an estimate of $1.58 based on what the software has estimated this part to look like. Now remember, we're just working with a picture file here and some dimensions that I typed in, so I need to now refine these estimates based on what additional information I might know. So the first thing I know is that it's not bent in 2 different directions, it's just bent in the one direction. So the software is assuming it's bent by that envelope height in both directions. So I need to correct these unfolded length and width dimensions. So the unfolded length and width of this part are actually 4.331 by 3.464. And when I do that, I can click calculate, and the software will re-estimate the appropriate sheet size and recalculate the number of parts that it would get out of a sheet. The scrap usage calculation has changed, and I've come up with a different estimate based on that envelope shape. Now the next thing I need to do is better define the geometry of the part. And so I've got now the envelope dimensions and the unfolded length and width of the blank, but over here, where I see the laser cut data and the press brake data, I need to specify that information. So the area of the blank, I can use each of these little calculators to calculate those values for me. So when I select the calculator next to the area of the blank, I'm presented with a calculator window where I can select the rectangular area, and that area of the blank was 3.464 by 4.331. The software calculates the area of that shape, and if I say OK, it transfers it into the analysis there for me. I can also estimate the cut area. So if I do that, I can select the perimeter lines here to define the different perimeters. Well, I'm going to cut 4.331, and there's going to be 2 of those edges if I think about the perimeter of the part. And then I have another edge that is 3.464, and I have 2 of those. And if I say OK, the software again will transfer that perimeter for me. Then I finally need, in this laser cut data group, to estimate the number of holes. I select the circular hole shape, and I've got, in this case, 4 that are 0.6 in diameter, so I'll add those. I've got 0.24 as a diameter, and there's 2 of those. And then I have 0.16 as a diameter, and there are 2 of those. And if I say OK, again, the software will transfer the number of holes and calculate the area and the perimeter of them for me. And then finally, I need to adjust the bends here. I can use the calculator, or I could just type it in. I don't really need to use this in this case because that bend line is 4.331. And if I make that change and say OK, the software estimates that for me. And if I click calculate, I get a very accurate at this point, estimate of the cost based on the geometry that I've input. Now, the thing we wanted to know is, would this cost less money if we stamped it on a progressive die? And so here I can see I've got 66 cents for the cost of this part. I'm going to rename this tab here to laser. And then I'm going to copy it, and I'm going to paste it. And I'm going to rename here, not laser anymore. This is going to be prog. And so now all the geometry information that I've inputted for the initial analysis has been transferred over here, and I simply select a process and a material, and now instead of laser cutting, I'll select sheet metal stamping on a progressive die. I'll choose the same material, and I'll say OK. A warning warns me that I'm deleting data specific to laser cutting. That's OK. And now the software has recalculated the cost for making that part on a progressive die for me. So I can see in the case of the original, that was 65 cents. And in the case of the progressive die, it's 16 cents, but I have to make a $20,000 investment in tooling. So the thing I might want to know is, at what production volume would that be cost effective? I can see that on the cost versus life volume graph in the results menu. By selecting that, it'll bring up a graph here that will show me a curve of how the cost comes down for the progressive die as I increase production volume. I can choose to add other analyses on here. So if I select laser, you can see here that the laser has been added as the blue curve. The red is the progressive die, and if I click right there, about 41,000 parts is where they roughly have the same cost. So production volumes greater than 40,000 parts, I'd want to invest in the tooling and achieve the lower piece cost. Then at production volumes less than 40,000 parts, I'd want to retain my capital and pay the higher piece part cost using the laser cutting process.